Hey everybody, welcome back for another day of the Advent of Code 2023 series. So today's problem is called Lens Library. As always, all the code for this problem and all the other days that I got through are in a repository in the description. And I'm Elliot, I build stuff, let's get stuck in. So here's a sample input for the problem for part one. It's a collection of short strings separated by commas. These strings can span over multiple lines. We're told to ignore the new lines, and we need to process each one of these segments. So Rn equals 1 is one segment, Cm minus is another, one by one, and calculate a checksum. Now the algorithm for the checksum here is pretty straightforward. We start at the value 0. We find the ASCII code of the current character. We add that to the hash or the checksum. We then multiply the value of the hash by 17, take the modulo 256, and then move to the next character and repeat from step 2. Once we've made it through all the characters in that segment, the final value is the value for our checksum. Pretty straightforward, so we can dive straight into the code for this one. Now, first up, we define this very small function for the computation of the checksum. And for part one, this is most of the work. So we take a string and return an 32-bit integer. We initialize the checksum to 0, as we said we do, loop through each of the characters, cast it to an unsigned 8-bit integer, which is the ASCII code in Rust. We then do the computation, so we add it to the checksum, multiply that by 17, and then take the modulo 256, repeat that for all the characters, and return the final value. So for a quick wrap up of part one, you can see we've omitted a bunch of part two code here. All we do is read the input file, replace all the new lines with empty spaces, split the contents on commas, compute each of the checksums, sum all of the checksums together, and we report that as our final answer. So part one here was a bit of a freebie, a nice and easy one before moving on to part two. So part two, the complexity increases a little bit, so let's jump straight into it. Now there's a couple of sample inputs from before. These would be comma separated in the input, but the problem states that we now have 256 different boxes with indexes 0 up to 255, one box for each of the possible checksum values. Because we take the modulo 256, that's all the possible values. And now we note that the different strings that we get as our inputs, they come in one of two variants. They either have an equal sign in them or they have a minus sign in them. So the process now for filling these boxes is we determine which variant we have. Let's say we'll start with the AB equals 1 example. What that's saying is we use the value AB to compute the checksum of just AB. That tells us what box we need to concern ourselves with. Then we need to insert into that box a lens with the label AB and the focal length of 1. If we already have a lens in that box with the label AB, we replace it with this new one. If we don't, we just add it to the end of the box. The minus sign variant is pretty similar. We calculate the checksum, in this case of DC. That'll tell us what box to look in. And this says if we have a lens in that box with the label DC, remove it. And if we don't, just ignore it and move on. So let's have a look at how we do this in code to place all of the lenses in the right boxes and then eventually calculate the score that gives us part two of this problem. So first up, we define a structure to store the label and the focal length. It's just a little lens structure here that makes it's easier to pop things into our boxes. Coming back to the main function, we also introduce just a place to store them. So 256 initially empty boxes that can be filled with lenses. Now, if you look back, you'll see we omitted some code within the loop last time. But now, as we loop through each of the different inputs, we have to check for the two different variants that we described before, the equal sign variant and the minus sign variant. If we get an equal sign variant, we split it left and right on the equal sign. We calculate the checksum based on the ID. We grab that box out of our list of boxes, and we check in that box if we found a lens with the exact same focal length. If we do, we update it. We mark that as found, and we exit out of our loop. If we get to the end of all of the lenses in that box and we haven't found a lens with that label, we simply add it to the end. The other variant we need to consider is the one with the minus sign. Pretty similar stuff here. We split it to the left of the minus sign, use that to compute the box based on the checksum. We look for a lens with that label within the box. If we get it, we remove it. If we don't, we just leave it alone. And that's the end of the changes for part 2. Then to calculate the final score is we loop through the final configuration of the boxes. We calculate a score here, which is dependent on the box and the focal length and a number of other things based on the order of lenses in the box, as described in the problem. Nothing too complex here, it's just the rules of the computation of the score. We sum all that up to the total focal length, we report that, and that is the end of part 2 of day 15. So a nice quick one here. Hopefully that was informative. Either way, I will catch you at the next one. I'm Elliot, I build stuff, and I'll see you then.